Hello everyone, welcome to my YouTube channel Logic Medico. Today's interesting topic is development of the eye. Before going into the development of the eye, if you are new to my channel, kindly subscribe to my channel Logic Medico and don't forget to press the bell button for the latest notification of the videos. So what is this coloboma of the eye? Can you see a slit in this eye over here? What is the embryological basis of this? So coloboma of the eye, in Greek coloboma, meaning a defect or a hole in one of the structures of the eye. Let it be like this iris. This is called the iris, the pigmented layer. Okay, or it can extend into the retina also posteriorly, or the choroid, or even the optic disc or optic nerve level. Okay. The next condition is persistence of pupillary membrane, or just called as PPM, persistent pupillary membrane. So you can see pupil is an aperture present in the iris. There are some web-like connections within this. So that is called as persistent pupillary membrane, like this. Please see here, this one. So it is a condition involving the eye where the remnants of the fetal membrane, persists as a strands of tissues across the pupil. So this will hinder the vision actually. So let's start with the development of the eye so that you can understand what is the embryological basis of the congenital anomalies. So development of the eye in totally sources, there are 4 sources from the neuroectoderm of the forebrain, which give rise to the retina, the posterior layers of the iris and the optic nerve. It's derived from neuroectoderm of forebrain. Whereas the surface ectoderm of the head region gives rise to the lens, the biconvex lens we have, that one, and the anterior epithelium of the cornea, which is a stratified squamous epithelium. It shows that it's coming from the ectoderm. Then the mesoderm, which is between the ectoderm and endoderm, or the brain area in this case, will give rise to the fibrous covering, that is the sclera of the eye, and the vascular coats, that is a choroid, the ciliary body. In addition to that, the interior of these neural crest cells, the junction between the surface ectoderm and the neural tube, will get detached as the neural crest. It gives rise to the sclera, choroid and corneal endothelium. So let's start with the development of the eye in detail. The development of the eye starts appearing in the fetus as early as 22nd day of the embryo as a pair of shallow grooves on each side of the forebrain. Please note, this is the forebrain, this is the developing neural tube. Okay, neural tube. So what happens in this neural tube? There will be 3 vesicles: forebrain, midbrain and hindbrain. Okay, the forebrain gives rise to the cerebral hemisphere. In that you can make out one groove is developing. What day? 22nd day of the embryo. These grooves are called as optic groove. So it develops from forebrain vesicle as a shallow groove called as optic groove. There are 2 in number, you can clearly see that. Okay, this is our head. Okay, this is the developing brain, forebrain. These are the optic grooves. So what happens subsequently? These optic grooves, first understand in the diagram, later you can see the notes. These are the forebrain vesicle and 2 optic grooves. The grooves become deepened to form a bulb-like structure. It's called optic vesicle. Optic vesicle. These optic vesicle goes and touches the surface ectoderm, the skin area. Okay, on the lateral aspect. So that ectoderm gets thickened. You can see that it's getting thickened, and it forms lens placode. This ectoderm will form a lens placode. The thickening of the ectoderm is called lens placode. There is an interaction between this optic vesicle and the lens placode. So what is happening? Optic vesicle is getting converted into a cup-like structure. It's called the optic cup, and the lens placode is being drawn into the cup. So 3 things you have to understand: deepening of the optic groove to form a bulb-like structure called as optic vesicle. Optic vesicle interacts with the surface ectoderm, forming a thickening called as lens placode, which gives rise to the future lens. This lens placode in turn activates the optic vesicle to form a cup-like structure like this. It's called the optic cup. So now you can see the notes. With the closure of the neural tubes, these grooves, that is optic grooves, will form an out-pocketing like a balloon, okay, of the forebrain called as optic vesicles. This one, okay. On contact with the surface ectoderm, these vesicles induce changes in the surface ectoderm, resulting in lens formation. So now it's called as lens placode. Future it gives us to lens. Shortly thereafter, the vesicles get invaginated like this to form a double layer cup. This is the outer layer of the cup and this is the inner layer of the cup. It's called the optic cup. So what happens to the fate of this optic cup? There are two layers, just now I told you, the outer layer of the optic cup and the inner layer of the optic cup. So this optic cup will give rise to the future retina. So between the two layers there is a gap, okay, that's the intraretinal space. The outer layer of the optic cup gives rise to the retinal pigment epithelium, while the inner layer of the optic cup gives rise to the remaining 9 layers of the retina. So the future of the optic cup involves, it forms retina. The fibers, the axons of these retina, ganglion cell layer of the retina, goes backward through the stalk called as optic stalk. This optic stalk, see, this optic stalk is the future optic nerve, but the nerve begins from the ganglion cell layer of the retina and goes backwards through a stalk called as optic stalk. The fate of the lens vesicle also, see here, lens placode becomes one vesicle, then it will have an anterior layer, posterior layer. Details I will tell you in the next slide. So the invagination which is happening in the optic cup is not restricted to the anterior aspect. You can see it's extending all the way on the inferior surface of the entire optic cup, including the optic stalk. So this fissure is called as choroid fissure. Okay. So this fissure, if there is failure of obliteration of this fissure, if you remember my first slide, that condition is called as coloboma. Normally this fissure should be there so that the structures which are developed inside of the eye should move into the eye through this fissure, choroid fissure. Later it should get obliterated or disappear. But if it doesn't disappear, if it remains like this throughout, then the condition is called as coloboma. So what happens, just now I told you, through this cup, through this fissure, choroid fissure, optic cup is getting choroid fissure. Now you can see that the mesenchyme, the mesoderm, along with one artery called as hyaloid artery, will enter the interior of the optic cup along with the lens. This lens vesicle, anterior epithelium remains thin, but the posterior epithelium gets elongated. It's getting elongated. Initially it's nourished by an artery called as hyaloid artery. Kindly remember this artery. This artery is now in the inside of the optic cup. Lens also is on the inside of the optic cup. This is a cut section. The outer layer of the optic cup, inner layer of optic cup, intraretinal space. Future it disappears. Intraretinal space disappears. So what happens to the fate of this hyaloid artery? So that you will understand, once this lens actually becomes the true lens, because the anterior epithelium and posterior epithelium is there, posterior epithelium proliferates rapidly to give rise to the collagen fibers. Okay, these collagen fibers are arranged parallel to one another and give rise to the biconvex shaped lens, and the space within that, the lens vesicle has got a space now. See the space. The space within this will be obliterated or it will be gone. So once this lens has actually become crystalline and transparent, we don't require this hyaloid artery nourishing the lens because it's only made up of fibers. So what happens? The hyaloid artery disappears, but not throughout. It will be present in this stalk area. So it will be present in the optic stalk area as a central retinal artery and vein. Along with artery, vein also will be there. Hyaloid artery and hyaloid vein fate. That part of the hyaloid artery within the eyeball or the optic cup area will disappear, while that part of the hyaloid artery within the optic stalk will persist as the central retinal artery. It is called so because it nourishes the retina from the center portion of the retina, then divides into superolateral, inferolateral, superomedial, inferomedial branches. So that is the fate of the hyaloid artery. Now what is the fate of the lens placode? I already told you, but I will repeat. Thickening of the surface ectoderm is called as lens placode, opposite to the optic vesicle. Later it gets depressed to form the optic cup. When the optic cup is getting depressed, the lens placode is been pulled inside, okay, by forming a pit and a cavity called as lens vesicle. What happens to this lens vesicle? What happens to this lens vesicle? The posterior epithelium proliferates to lay down the collagen fibers parallel to one another. So lens vesicle also disappears, give rise to the solid crystalline lens made up of parallel collagen fibers. You can clearly see that here. Anterior epithelium remains short, posterior epithelium is elongated to form the collagen fiber, and you can see the lens vesicle becoming obliterated. At the same time, through the choroid fissure, the surrounding mesoderm will be there now, that is invaginating into the eyeball. So behind the lens there is one jelly-like material. You can see one of my videos on the layers of the eyeball. That time you will understand better. This area is the jelly-like material. It will give rise to the vitreous humor. whereas this surrounding mesoderm which comes in front of the lens will give rise to liquid like material. It's called the aqueous humor. The remaining portion of the adjacent mesoderm which encircle this optic cup area will give rise to the sclera. Mesodermal cells which are just around the retina, I told you the outer layer of the optic cup will give rise to the pigment cell layer. You can see dark pigmented black color. Okay, the remaining neuronal cells, can you see? This is the inner layer of the optic cup, give rise to the remaining 9 layers of the retina. Just underlying the sclera there is one vascular layer, it's called the choroid, and here it becomes triangular body called ciliary body. Here it becomes a curtain called as iris. So that is the fate of the adjacent mesoderm. So in summary, the development of the retina, if I want to tell, the outer layer is there. Outer layer of the optic cup give rise to retinal pigment epithelium, whereas the inner layer of the optic cup give rise to the remaining 9 layers of the retina. The intraretinal space disappears. So there is a fusion between outer layer of optic cup, you can see that here, inner layer of optic cup. The artery which was supplying the lens, it's not called lens artery, it's called hyaloid artery, disappears within the eyeball, and a jelly like material will be present behind the lens, it's called as vitreous humor. This artery will be present within the optic stalk as the central retinal artery and the vein. So out of all these layers, you just have to understand a pigment cell layer of the retina is derived from outer layer of the optic cup. Remaining all the 9 layers including this ganglion cell layer and the optic nerve fiber layer will be developed from inner layer of the optic cup. Okay, inner layer of the optic cup. The axons of these will dip into this, the axons of ganglion will dip into this optic stalk as the optic nerve fibers. Okay, so what happens to this anterior portion of this optic cup, this area? So what happens to this? The anterior 1/5 of this retina inner layer will be continuous as the inner layer of the ciliary body. It will be continuous with the inner layer of the iris. That's good enough. Don't worry about this complicated name. You just have to know inner layer of the ciliary body and inner layer of the iris. So the junction between the optic cup, this optic cup, and the overlying surface epithelium is filled up by mesoderm. This I already told you. So this mesoderm not only encircles the future eyeball or the optic cup, but also goes inside the eyeball to form the vitreous humor. So the ciliary body, how it is developed? It is developed from the part of the anterior 1/5 of the inner layer. Inner layer, see this one, neural layer of the retina, it's going inside. So the posterior aspect of the ciliary body is developed from inner layer of the optic cup. The pigmented outer portion of the ciliary epithelium is derived from outer layer of the optic cup. This layer is derived from outer layer of the optic cup. This black color one is the other one, outer layer of the optic cup. The non-pigmented portion obviously is derived from a epithelial layer. The muscle within this, the ciliary muscle, is derived from mesoderm, mesenchyme. So I repeat, the innermost aspect of the ciliary body is derived from inner layer of the optic cup. The pigmented layer of the ciliary body is derived from outer layer of the optic cup. The connective tissue in this is derived from mesoderm, including the ciliary muscle is derived from mesoderm. The non-pigmented epithelium in the anterior portion will be in the ciliary body. The non-pigmented epithelium is derived from the neural retina. Okay, so same thing is continuous with the iris also. I can tell here only the inner layer of the iris is derived from inner layer of the optic cup. The pigmented layer of the iris is derived from outer layer of the optic cup, whereas the sphincter pupillae and dilator pupillae muscles of the iris are developed from ectoderm. Okay, please remember that the sphincter pupillae and dilator pupillae of iris are derived from ectoderm. The remaining connective tissue and all are derived from adjacent mesoderm. So same thing is given over here. So the unpigmented layer is derived from inner layer of optic cup, whereas the pigmented layer of the iris is derived from outer layer of the optic cup. The connective tissue framework, just now I told you, is derived from adjacent mesoderm and the neural crest cells, whereas these two is very important. The dilator pupillae controlled by sympathetic nervous system, sphincter pupillae controlled by parasympathetic nervous system. These muscles are developed from the surface ectoderm, which is just overlying the developing iris. Development of lens is very interesting. It is derived from the surface ectoderm by a thickening called as lens placode. That lens placode will develop a depression called lens split and develops a cavity called as lens vesicle. So the anterior wall of this lens vesicle will not proliferate that much rapidly. It will remain as cuboidal epithelium. Posterior layer will proliferate rapidly to form. It will elongate first tall columnar, later it proliferates and give rise to lens fibers. These lens fibers are called as primary lens fibers. Subsequently, in the equatorial zone, that is in the middle of this is the anterior pole of the lens, this is the posterior pole of the lens. This is your eyeball, okay? Will be optic nerve will be here. So between the anterior pole of the lens and posterior pole, midway is called as equator. uh, Second set of fibers will be developed because of the elongation of these columnar cells. They are called as secondary lens fibers. It is these lens fibers which is going on to the adulthood life. Okay, the nutrition for this lens initially is derived from an artery called as hyaloid artery. This also I have told you in detail, hyaloid artery, which subsequently degenerates, but subsequently there will be a jelly like liquid behind the lens, if you remember, vitreous humor, and one watery liquid in front of the lens called as aqueous humor. So these liquids which are in front of the lens and behind the lens, in front of the lens aqueous humor, behind the lens vitreous humor, will now start nourishing the lens. The lens, if a blood vessel is there, what can happen? You only think, use your logic. Whenever you are seeing any object, you can't see the object, you can see blood vessel. Even the sky, in the ground, whatever you see, you will see blood vessel only. So therefore nature disappears the blood vessel which is actually there. Otherwise you can only see the blood vessel. Therefore a liquid is there, clear liquid in front, aqueous humor, and a jelly, clear jelly behind, vitreous humor. So there will be a covering for this lens. It's called tunica vasculosa lentis. That is future it becomes the capsule of the lens. There is two capsules, anterior capsule, posterior capsule. The anterior capsule is now called as pupillary membrane. So what happens when the blood supply gets cut off? Even the membrane should disappear. Okay, if it disappears, then the lens will become transparent and clear. If it doesn't disappear, you remember persistent pupillary membrane. Yeah, that will happen. If you are able to remember, in the initial part I have showed you one persistent pupillary membrane. If this pupillary membrane normally it is there, okay, in the initial part, subsequently when the hyaloid artery disappears, the pupillary membrane also should disappear. If it doesn't disappear, that is resulting in a condition called as persistent pupillary membrane that will inhibit vision or hinder vision. So that is shown here. The hyaloid artery which is there over here, the vitreous jelly, it disappears here only in the distal part. Proximal part it persists within the optic nerve and within the retina, nourishing the retina from center. So we call it as central retinal artery. Central retinal artery. This will remain as hyaloid canal. One tunnel like thing area will be there within the center of this jelly. That shows that there was a hyaloid artery. So here you can see there was a capsular pupillary membrane. Can you see it disappearing here? Here it's not there. See, if it doesn't disappear like this, if it persists like a web, it will be here. It's called as persistent pupillary membrane. Development of vitreous body is very simple. Vitreous body is developed from the adjacent mesenchyme. So this vitreous body, the mesenchyme which is surrounding not only the eyeball, which also invade the interior of the eyeball. Within these hyaloid vessels, it will engulf this lens and it will encircle the interior of the optic cup. So this forms a delicate network of fibers between the retina and the lens. The interstitial fluid with a delicate gelatinous substance forms the vitreous body. Hyaloid vessels disappear, leaving behind a hyaloid canal. One tunnel like thing will be there. That shows that there was a hyaloid artery. Same thing is shown here. Undifferentiated mesoderm encircling this will form the sclera and the choroid. Those which pass through the choroid fissure, a gap will be there now on the inferior aspect. Through that it will enter the eyeball behind the lens in front of the retina, will give rise to the vitreous humor or the vitreous body. Come to the development of chambers of the eye. There are two chambers, anterior chamber and posterior chamber. Both are in front of the lens. Anterior chamber is that portion between the cornea and this iris. Future iris will come here. Posterior chamber is that chamber between the iris and the lens. So anterior chamber is a cleft developed between the iris and the cornea, whereas the posterior chamber is a cleft between the iris and the lens. So it is developed from the adjacent mesoderm. In both these chambers, anterior chamber and posterior chamber, a liquid is filled, 99.9% water. That liquid is called as aqueous humor. So development of aqueous humor. When the pupillary membrane disappears, that membrane in front of the lens, okay, it disappears, the pupil forms the anterior and posterior chambers of the eye are able to communicate with one another. That is, this edge of the optic cup is there and it will project like this and it will form one pupil. Okay, pupil is an aperture. So in front of the pupil, anterior chamber, behind the pupil, posterior chamber. So a clear aqueous humor circulates from the posterior chamber towards the anterior chamber and provides nutrition for the lens, this cornea and the iris. This clear fluid initially is formed by the ciliary body, subsequently it drains from the posterior chamber through the pupil into the anterior chamber, and then through the canal of Schlemm through the scleral and episcleral vein it will drain. You can see one of my video on the aqueous humor, production, circulation and drainage. Now, development of the sclera and choroid is very simple. Under the inductive influence of the retinal pigment epithelium, this pigmented epithelium, the surrounding mesoderm will get thickened to form the outer fibrous connective tissue coat called a sclera and an inner vascular pigmented coat. Here, blood vessel is there. Blue and red color noodles will come. That is called as choroid. So, the sclera is continuous forward with a transparent covering called as cornea. This cornea, only the anterior epithelium of the cornea is derived from surface ectoderm. The remaining layer of the cornea is derived from adjacent mesoderm. The choroid projects forward as the ciliary body and the iris. Okay. The choroid, ciliary body and iris together is called as uveal tract. All these are derived from mesoderm. Some authors tell they are derived from neural crest. Come on to the development of cornea. Just now I told you, after the formation of the lens vesicle, then there is formation of the cornea by transformation of surface ectoderm into a transparent multi-layered epithelium, multi-layered structure called avascular cornea. Avascular means no blood vessel is there. So cornea has got 5 layers basically. The external corneal epithelium, that is the anterior epithelium of the cornea, is derived from surface ectoderm. It's a stratified squamous epithelium. That only shows that it is derived from surface ectoderm. Below that there is a Bowman's membrane, then there is a corneal stroma, then there is a basement membrane. All these layers is derived from mesoderm, adjacent mesoderm, connected tissue mesoderm. Where the internal corneal endothelium will be there, inside inner part, it's derived from neural crest. So I'll repeat. In general, the anterior epithelium of cornea or the external epithelium of the cornea is derived from surface ectoderm. The internal epithelium of the cornea or the endothelium is derived from neural crest. In between these two epithelium is derived from so it's derived from mesoderm. It's very simple. So in summary, so if you want one more line, I can tell about the eyelids. These are the eyelids, nothing but reduplication of the ectoderm. See, initially the ectoderm will be like this here. It's only like this one layer, so there is a reduplication, meaning folding of the ectoderm upon itself. Just imagine like a fold of a shirt or a fold of a trouser. Okay, like that, a reduplication. If the trouser is too long, you will fold it upon your own ankle, right? Like that. When there is a reduplication of the ectoderm, with the adjacent mesoderm invading it, it will project it like this and give rise to the eyelid. So within this eyelid, the muscle orbicularis oculi, you can see one of my video on that. Orbicularis oculi, muscle of facial expression derived from hyoid arch or the second branchial arch. So thereby supplied by fascia will invade this area. So this reduplication will give rise to the eyelids. So eyelids initially they are fused, later the cleft will open and this lining epithelium of the inner surface of the eyelid and the anterior surface of the eyeball will now form conjunctiva. It is stratified columnar epithelium. In summary, the development of the eye into this conjunctiva opens the lacrimal gland. Lacrimal gland is a tear gland. It will open from here. So actually they are developed from the outpoaching from the conjunctiva. Okay. In summary, the development of the eye is derived from 4 sources. The neuroectoderm of the forebrain, that is the optic groove, optic vesicle, optic cup will give rise to a retina, posterior layer of the ciliary body and iris, and also the fibers beginning from retina, ganglion cell layer of the retina forms the optic nerve. The surface ectoderm of the head region where the eyeball comes and touches, first it gives rise to the lens placode. Lens will be invaded within the optic cup. Later it gives rise to one epithelium, the external epithelium or the anterior epithelium of the cornea only. The mesoderm between the above mentioned layers will give rise to everything. The fibrous covering of the eyeball, the sclera, the choroid, vascular covering of the eyeball, the ciliary body, everything. The connective tissue framework of the eyeball is derived from the mesoderm, okay, including the chambers. You know, vitreous humor, aqueous humor, anterior chamber, posterior chamber, all these are derived from mesoderm. The neural crest cells contribute to the part of the choroid and the sclera and the corneal endothelium. This is 100%. These two are, some authors tell they are derived from mesoderm, some authors tell they are derived from neural crest. Partly both authors are correct. So colobomum of the eye is a cleft, defect or a hole in the structure of the eye. It can be limited to the iris, it can extend to the ciliary body or the retina also. and choroid optic disc as well. The embryological basis for this is in second month of the intrauterine life, optic fissure, also called as choroid fissure or the embryonic fissure, usually should close to form the structures within the eyeball. When the optic fissure or the choroid fissure fails to close or does not close completely, it will result in coloboma. This can be incomplete coloboma. It can be only in the iris. I already told you. It can extend throughout the eyeball. That is complete coloboma. Okay. So failure of closure of choroid fissure or optic fissure results in coloboma. Next, after coloboma, it may be associated with one more condition: persistence of pupillary membrane. So persistence of pupillary membrane. What is the reason? I just now told you. Pupillary membrane is a membrane in front of the lens. So normally hyaloid artery supplies the lens. Hyaloid artery, when it degenerates or disappears, even the gift wrapper covering the lens, that is the anterior capsule of the lens, should disappear, which is around the pupil. If it does not disappear, if it persists, we call it as persistent pupillary membrane. It creates a web like formation in front of this iris margin over here, which will hinder the vision or obstruct the vision. It's called as persistence of pupillary membrane. Next, cyclopia and anophthalmia. Failure of absence of development of the optic cup and all will result in anophthalmia, no eye at all. Cyclopia is a condition in which there is only one median eye and the nose projects upwards above the median eye. And this child is not compatible with life. This nose will be called as proboscis. Thank you for watching my video. Kindly subscribe to my channel and press the bell button to get the latest notification of the videos which I upload. Don't forget to press the thumbs up button if you like this video and learn from this. Kindly share this video with your family and friends, especially the friends who are of same batchmates. Let them also learn this or better revise from this. Thank you once again for watching this video.